This is an example problem of doing properties of functions kind of all combined together. In the previous videos, you looked at sort of each of these things individually, so we're just going to kind of combine it all together. So looking at this function, f of x equals the square root of x minus 4 over the quantity x minus 3, we want to describe all the properties of this graph. So we're going to start with the domain. Remember, you can find domain algebraically or from the graph, so you could use the graph to find that. I'm just going to review it algebraically. So remember, algebraically, we're going to look at, is there a variable in the denominator of a fraction? And there is. So remember, x minus 3, we're going to set that equal to 0. So x equals 3. X equals 3 cannot be in our domain. Also, we have that radical there, so 4 minus x has to be greater than or equal to 0. So negative x is greater than or equal to negative 4, and x is less than or equal to 4. Combining these two things together, we have here all the values less than or equal to 4. And then up here, this one says x can't be 3, so we're going to have to take out that 3. So then we're going to say our domain is all values from negative infinity to 3, and then from 3 to 4. We're including the 4, but not the 3. We could also see that from the graph. If we kind of travel across this graph from the left, we're going to the left forever. We're hitting all of these x values until we get to here where this asymptote would be. So that is appearing to be at 3, and then on the other side of 3, we're coming down here to 4. Remember, on your calculator, you can use this to check a couple things. If you're looking at the graph and thinking that your asymptote appears to be at negative 3 or positive 3, check x equals 3, y is undefined, so that confirms that. If you're not sure if you should include this value of 4, again, check that. X equals 4, y equals 0, so that point exists. If we go a little bit past that, 4.1, y is again undefined. So that kind of helps you confirm your domain from what we did algebraically. Remember that for range, we're just going to get that from the graph. So from our graph, we can see this appears to be going down forever, and then this piece of the graph includes all of the negative values. We're approaching 0, but not getting to 0. Over here, we are getting 0. We just checked that on the calculator, and then we're going up forever. So it appears then that our range is going from negative infinity to positive infinity, so all the values there. So next we want to look at, is this a continuous function? And obviously when we trace this graph, we start tracing from the left. Here we're going to have to pick up our pencil at that asymptote and sort of jump over it. So this is not a continuous graph. So we're going to say that we have a point of discontinuity at the x equals 3 value. Again, we want to look at next where this graph is increasing and decreasing. So I'm going to start tracing from the left. As I'm tracing from the left, these y values are getting smaller, so we are decreasing. Then I have to stop where this asymptote would be and jump over it. And then I continue tracing this graph, and it's still decreasing. So this whole graph is decreasing. So we're going to say that this graph is decreasing from negative infinity to 3, and then again from 3 to 4. So we have to make sure that we put that in there to indicate to someone that there is a break at the 3. So no increasing value, so we don't have to write that at all. Next, we want to talk about any extrema. Do I have any maximums or minimum values? So I don't have any overall absolute max or min values because my range is going from negative infinity to positive infinity. But right here, I do have a local minimum. We have a local min. And that is at the point 4, 0. So next we want to talk about the boundedness of the graph. So this graph goes down forever, this graph goes up forever, so the graph is unbounded. Symmetry, remember when we're talking about symmetry, we would just want to say even or odd, and this graph is neither even nor odd. I'm just going to say neither even nor odd. Next, we need to talk about the asymptotes of the graph. Remember, for the asymptotes, we want to look at the vertical asymptotes. The vertical asymptotes come from where my denominator would be undefined, and then my limits approaching that value are positive or negative infinity. So we can see that we have a vertical asymptote here at x equals 3. So vertical asymptote at x equals 3. And then for my horizontal asymptotes, as we go to the left on this graph, we're approaching that value of 0. So I can see from the graph that I have a horizontal asymptote at y equals 0. Remember, for horizontal asymptotes, we can use those rules about degree of numerator and denominator. The degree of my numerator here would be 1/2. The degree of my denominator here would be 1. So the degree of my numerator is less than the degree of my denominator. And remember, by our rule, that says that our horizontal asymptote is at y equals 0. Since I have that horizontal asymptote, that tells me that my end behavior is bounded. And that gives me all of the properties of my graph.